Yesterday we talked about our matrices and finding the determinant. Now, the determinant basically measures what?
The area.
Yeah, the area. Yeah, it measures all sorts of stuff, but we use it most to measure area. And as I said before, since it measures so many different things, what we're going to do now is we're going to use it to measure the x value or the y value. And so how we do that is by using the determinant. And since Cramer's rule is a little bit different, I'm just going to show you that first little step so that we can make sure we've got this. What I like to do is I like to highlight my variable portion right here, okay? And this sort of helps me keep on track. And I'm going to use the determinants to solve for variable x, right? And we've done systems of equations back in Algebra 1. We did the graphing method, the substitution method, the elimination method. So this one is just a different method to solve. Some math teachers require you to do Cramer's rule for both the x and the y variable, but I believe in being smarter and not working harder. So we're going to do it one time, and then we're going to take that value and plug it in. So yeah, it just makes our life a little bit easier. So I'm going to set this up. It's going to be a 2 by 2 divided by a 2 by 2. And really, we're not like taking the 2 by 2 and dividing it. We're finding the determinant of the 2 by 2. That gives us a numerical value, which we can then divide. So the denominator is super easy. It's just whatever is the numbers here, we bring over. And when we use those numbers without the variables, what did we just do to that matrix? It starts with an A. We talked about it day 1. No, we're not adding, no. When we take just the coefficients and leave the variables, we call that augmenting, yeah. Augmenting the matrix, okay? So we have now augmented that matrix. And now to get the numerator, what I'm going to do is I'm going to take my solutions that I have over here, and I'm going to replace my x values with it. So it's going to look like this: 7, -3, and then whatever we have here just transfers on up. You know what I mean? So it's going to say -2 and 4. Okay. Thank you. That's my goal in life, to be cute. Okay, so then from here, I can go ahead and find the determinant. So I know it was yesterday and it's been a minute, so let's just pretend like we've never seen it before. We need to start with the top left-hand corner, right? That's the first diagonal we need to start with. So 7 times 4 gives me 28 minus, and then we do the next diagonal. The -2 times -3 is a 6. Very good. 28 minus 6 gives me... Perfect. All right. Now we're done with that. Let's move on to the denominator. So we're finding the determinant of this. It's going to be 12 minus minus a negative, which becomes a plus 10, and that gives me 22. Now remember, we're taking the determinants and we are dividing. So x is going to equal 1. Exactly. Once I have this, I'm going to plug it into either of my equations. I usually pick whatever one looks the easiest. So like the 3 is smaller to me, so I'm going to pick the first equation. But if you pick the second one, you'll get the same answer. So I work this out, and I subtract my 3 over, divide by that -2, and I get a y value of -2. Now remember, I don't know if you remember, but in Algebra 1, when we write our answer as an ordered pair. So our answer is not just 1 and then -2. It is the ordered pair, 1, -2. And then please make sure you box in your final answer, because we do have a lot of work here, so it would just benefit us. And I'm actually going to transfer this information over just because my OCD. All right, so we're going to start the next one together, and then I'll let you guys, nope, that's not how that works. I'll let you guys work on it by yourself. So on the right-hand side, that's the one we're going to focus on really fast. Right-hand side, first things first, I'm going to highlight this to make my life a little bit easier. Solving for x, it's going to be a 2 by 2 determinant over a 2 by 2 determinant My augmented matrix with the 4, 5, 2, and 3, is that going to be my numerator or my denominator? Yeah. Okay. And then for my numerator, how do I incorporate my solutions? And I replace it with the x column. Very good. So that's going to say 6, -4, and then bring over the normal y column, yeah. All right, take a couple seconds and find the determinant, please. All right, so what did we get for our determinant as the numerator? 18 plus 20, which gives us 38. And then, no, you're fine. And then our denominator would be, okay, and this gives us a value of 19. Okay, so then I take the 19, and what do I do with it? Plug it in. Which equation would you guys like to use? Bottom one. Yeah, it's a little bit smaller, so let's use that one. So it's going to be 2 times 19 plus 3y is equal to -4. Okay, that's going to give me a 38 plus 3y is equal to -4. We can subtract this over and get 3y is equal to 42. Excuse me, -42. Thank you. It's a little cramped. Let me make it nice and a little bit more obvious. All right, and then from here we divide, and -42 divided by 3 gives us... Very good. But do we leave our answer like this? No, we have to write it as an order pair. So it'd say 19 and then -14. And make sure you box it in since there's a lot of work happening. Yes, it is an order pair. Yes, Reagan. It does not matter. It will give you the same answer either way. Good question. Okay, so go ahead and do letter B on the left. It's very similar, and then we'll come back and give our final answer. So, what did we get as our answer for letter B? 2, -2. Very good. Is there anybody who's like, could you maybe just like go through those steps? Okay, wonderful. Okay, let's move on to the next part. We have solved systems of equations with a 2 by 2. But now let's look at a 3 by 3. I know, it's going to be so much fun, I promise you. We're going to divide and conquer. I'm not going to make you guys do all of it. It's just, it is a lot, you know? And I'm actually going to keep this space up here, oh gosh, hold on. Up here blank, so that we can sort of use this space to do a little bit of work, because I don't think there's enough room on this little section I've given you. So here we go. The process is very similar, but notice how I have 3 variables, which means I need to do the work for x and y, right? I know, but it's okay. We're going to divide and conquer, and we're going to get through it. And we're going to do one of them all together so that we can remember how to do a 3 by 3. So first things first, I'm going to go ahead and highlight, because that just visually helps me keep on track. I'm going to highlight this variable portion, and I'm going to set up my x information, right? My denominator is going to be the highlighted portion, so I'm just going to go ahead and copy that piece down. So it's going to be -1, 1, -3, 4, -2, 5, -3, -1. Please make sure you put a negative on that final one. I've had a lot of people in the last hour, when they were copying this down, they just forgot that negative, and then all their answers were wrong, and there was much crying and gnashing of teeth. Okay, so then we come to the y. It's going to be very, very similar. And again, I'm just putting this information sort of off to the side. And it's going to be very similar with our denominator. It's, in fact, the same thing. So I'm just going to go ahead and copy that information over now. Okay, so I have copied over the determinant, the 3 by 3 determinant for both of these. Get rid of that word so I have a little bit of room. Okay, and now what I'm going to do is I am going to take my solutions. If I'm solving for x, I need to replace the x column with these numbers. So it's going to say 21, -5, -17, and then all these pieces down in the denominator, that's just transferred up. So it's going to say -3, 4, -2, 5, -3, and negative, make sure you have that -1. Okay, so that is what we're going to do for the x. Let's go ahead and write the information for the y. So again, I'm going to take my solutions, but instead of plugging it in for x, well, now I'm going to plug it in for y. Yeah, exactly. Plug it in for y. So this is going to be my center column. So it's going to say 21, -5, -17 in the center. And then these columns are basically the same. They're transferring up. It's going to say -1, 1 and 1, 5, -3, and negative, make sure you remember the negative, 1. All right, now let's pretend like we have forgotten how to do a 3 by 3. Since we're going to have to do 2 3 by 3s anyway, we're going to do the denominator together because that is what it's going to be the same for all of us, right? So I'm going to use the space up here for that. And before I get started, I'm going to put my positive, negative, positive. It just helps me keep track of everything. And up here in this space, I'm going to put my positive, -1, my negative, -3. And if you want to put a positive 3, that's fine, same thing. And then my positive 5. So I took my first row and I broke it apart. And now I'm ready to put my 2 by 2s. All right, so my first 2 by 2 is going to be that 4, -2, -3, -1. And the reason why that happens is because when I pull this one, it basically cancels out its row and its column, and those are the numbers that are left over. Okay, then I do the same thing again for the 3. If I pull the 3, it cancels out its row and its column, and now the numbers that are left over are the 1, 1, and the -3, -1. So I'm going to go ahead and put that 1, 1, -3, -1. Then I come to my last one. Here's my 5. It basically cancels out its row and its column, and I'm left with that sort of bottom left-hand corner of numbers. So it's going to say 1, 1, 4, -2. I know, it's a lot, but again, we'll divide and conquer. So the first portion is going to say -1, right? It's going to say -4 minus 6. Is there anybody who is confused as to how I got that? Okay, so remember, this negative right here is just part of the formula. It's part of the process. Okay, so then we come to the next part. It's going to say +3. It'll be -1 minus a -3, which becomes a positive. Okay, then we come to our last portion. It's going to be 5 times -2 minus 4. And then from here, it's pretty easy. We'll just make sure all our signs are good. This gives me a 2 right here. This will be a -6. We plug this into our calculator at this point, or you can do by hand. It's the same thing. And we should get an answer of... Nope.
-14?
That is correct, -14. Okay, so we know that all of our denominators are going to be a -14, so I'm just going to go ahead and fill that in, -14, -14. Okay, and then now we're going to divide and conquer the numerators, right? Because we have 2 different 3 by 3s, and it's just a lot, okay? So if I can have my group of 4 over on the left-hand side, you guys can do X. Oh, gosh. You guys can do X, and then this half of the class, you guys can do the Y. So you're just doing one more 3 by 3. If you want to work together, you can. If you want to do it separately and then compare answers afterwards, you can. But these are going to be whole numbers, and they are going to be numbers larger than 14. Yes, ma'am? X. Y.
How is that a +6 in the middle?
How is it a +6 in the middle? Okay. All right, go ahead and work on that. Let's go through this. If you were doing the X one, and I'm going to put it in, I guess I'll do blue, it's fine.
So what is
-14 is the determinant of the denominator, the 3 by 3 of just the normal augmented matrix. So we did that one together to review how to do a 3x3. So then you guys were doing the numerator. So if you did the x value, I'm going to start with x. It should be 21 times negative 4 minus 6 plus 3 times, sorry, I'm doing this in my head, so just give me a second, 5 minus 17 times 3, 17 times 3 gives us a 51. Yep, that sounds about right. And then finally, our last one should be a plus 5 times a 10 minus a negative 17 times 4, which is a 68. Okay, this is going to give us a 21 times negative 10, a negative 46, and a 78. We plug all that into our calculator, right? And we should end up with a 42. 42. A positive 42, yes. And then from here, we can reduce that, and it gives us a negative 3. So x is going to equal negative 3. So then let's look at the y one, because you guys said you were struggling with that one. If we look at the y values, it should be a negative 1 times 5 minus 51. Right? Double check me, please.
Yes.
Okay. Negative 21 times negative 1 minus a negative 3. Is that what you guys got? Mm-hmm. Okay. And then finally, we have a plus 5 times negative 17 minus a negative 5. So this will end up being a negative 46. This will end up being a 2. And then the last parentheses will end up being a negative 12. Plug all that in, and we should get a negative 56, which gives us 4. Exactly. Okay, so once we do all that, right, and again, like you didn't have to write down the work of the other group, all right? I just did that to make sure that whatever group you were in, you could just double check your answer and find any sort of mistakes. But once we determine our x and our y value, we can now plug in for the to solve for z. So which equation would we like to use for that? Okay, so I hear 2 for the bottom one, so let's go ahead and use that one. It's going to say negative 3 minus 2 times 4 minus z is equal to a negative 17. Go ahead and solve for z, please. If you have your answer, just raise your hand. I'll come by and I'll check it. All right, so if you do it correctly, you should end up with a positive 6, right? And then the question was, well, how do we write our answer? We write our answer just like we did in our 2x2s. It's going to be x, y, and then followed by z as an ordered pair. So our ordered pair is negative 3, 4, and 6. This is when we start incorporating the z axis. It is a third dimension. It's a third dimension. We don't do it a lot in Algebra 2. You see it a lot in calculus. Okay, but listen, it's fine. It will be fine. All right, any questions before we move on?
Do you ever need to use calculus in real life?
I use calculus all the time.
Because you're a math teacher.
Well, you didn't ask me to specify, so yes, I use math all the
I
time.
remember there was a board in Miss Kinder's room. He's like, "What you need math for? To be a baker? Is it to be a baker?"
Well, yeah, there's a lot of fractions if you convert and stuff like that. Yeah, one time I made cream puffs and I had to, the recipe was like for a restaurant, and so it made about 1,000, and I was like, that's not what I want. I don't need 1,000 cream puffs. So I did have to like divide everything by a 6 or something. Anyway, so you guys have the rest of the class period to work on the homework. We're gonna skip that last problem.
It's all on bad ideas.
It is on big ideas.